So after the sign convention, I'm just preparing a table of sign which will help you out in the numerical. We have studied U is object distance, and we know object distance is always negative. Irrespective the mirror is concave or convex, U is always negative. V, that is image distance. We know real image is formed on the same side, that is on the left hand side, and virtual image is formed behind the mirror, that is on the right hand side. So if the image is a real image, the image distance is measured on the left hand side of the pole, so it would be negative. And if the image is a virtual image, the image distance is measured on the right hand side of the pole, so it would be positive. Now V for concave mirror, we know concave mirror gives both kind of image. In the first 5 ray diagram it gives real image, and for the last case when the object is between P and F it gives a virtual image. So for a concave mirror the image can be real as well as virtual. So we can say image distance for concave mirror is negative when if the image is a real image, and it is positive when if the image is a virtual image. Convex mirror, we very well know convex mirror always gives a virtual image. A virtual image is formed behind the mirror. Behind the mirror, therefore V should be positive. So for convex mirror, V is always positive. Why? Because a convex mirror always gives a virtual image, and a virtual image is obtained behind the mirror. So the image distance would be on the right hand side of the pole. F, focal length. For a concave mirror, the principal focus is on the left hand side of the pole, so focal length is negative. For convex mirror, the principal focus is on the right hand side of the pole, so focal length is positive. Same holds for radius of curvature, that is radius of curvature, that is center of curvature. The principal focus and center of curvature lie on the same side. So radius of curvature would be negative for concave mirror and it would be positive for convex mirror. H, height of object. We know height measured above the principal axis is positive, measured below the principal axis is negative. An object is always kept above the principal axis, so height of the object would be positive. So irrespective whether it is a concave mirror or a convex mirror, H will be positive. H dash, height of the image. We can understand image if real will be obtained below the principal axis, and if virtual it will be obtained above the principal axis. So if the image is real, the height of the image would be negative, and if the image is virtual, the height of the image would be positive. For concave mirror, we know concave mirror gives both kind of image, real as well as virtual. So the height of the image would be negative if the image is real, and it would be positive if the image is virtual. Convex mirror always gives a virtual image above the principal axis, height of the image would be positive. Next, formulas which we will be using to solve the numerical. First formula. The first formula is mirror formula. The formula is called as mirror formula. Now what is the mirror formula? A formula which gives relationship between the object distance, image distance and focal length is called as mirror formula. A formula giving a relation between object distance, image distance and focal length of a mirror is called mirror formula. What is the formula? 1 by V plus 1 by U equals to 1 by F. The second formula is for linear magnification. Important concept. Now what is linear magnification? Linear magnification is the ratio of height of image to height of object. Linear magnification is the ratio of height of image to height of object. It is denoted by the alphabet small f. So m equals to h dash by h, that is height of image by height of object. From the value of m, we can infer whether the image is a magnified image, diminished image or same size. if h dash by h, that is height of image by height of object. If height of image is equal to height of object, value of m would be 1. So what does m equals to 1 signifies? It signifies that the height of image equals to height of object. Now if height of image is greater than height of the object, the value of m would be more than 1. That is, if the value of m is more than 1, we can conclude that the image is a magnified image. And if h dash is less than h, that is height of image is less than the height of the object, then the value of this fraction will be less than 1. So less than 1 value of m suggests that the image is a diminished image. That is one way of looking at it. Second thing, what can we infer from the sign of m? We know h is height of object, and we know height of object is always positive. So in this fraction, the denominator is always positive. So the value of m would be the sign of m would be the sign of h dash. If h dash is positive, m is positive. If h dash is negative, m is negative. Now what is h dash? Height of image. When is h dash positive? If the image is virtual. When is h dash negative? If the image is real. So if h dash is positive, that is when the image is virtual, m would be positive. And if h dash is negative, that is when the image is real, m would be negative. It means if m is positive, the image is a virtual image, and if m is negative, the image is a real image. This can also be equated to minus v by u. That is minus image distance by object distance. And last one relationship. This is f equals to r by 2. That is, focal length is half the radius of curvature. Maybe in numerical they give that a concave mirror has a radius of curvature 30 centimeter. Then you should understand that if radius of curvature is 30 centimeter, the value of f would be 15 centimeter. Okay, so please prepare this topic well. It would help you in the numericals. Thank you.